What is going on, guys? Welcome to this computer vision tutorial. In today's episode, we're going to work with edge detection and edge filtering. So we're going to use the video data that you see in the bottom right corner here, my webcam, as an input for that, and we're going to apply some edge detection and edge filtering onto that. We'll see some quite impressive results here. But of course, I'm going to have to shut off the webcam from time to time so that I can use it in Python, because it's not possible for me to use it for recording and for Python at the same time since I'm using one webcam. But that shouldn't be that much of a problem here. The results are quite impressive, so let us take a look at what we're going to end up with. So I turned off my camera right now to show you what the end result will look like. So let's run a script here. And you'll see that I use two filters here. One is the Canny filter, or the Canny effect, the Canny function. And the left one is the Laplacian filter, the Laplacian function, whatever. And what you can see here on the right is that the edges are really almost the only thing that gets highlighted. Maybe a little bit too much, maybe too many edges, not only the outer edges, but also the details in my hand, for example. But we can reduce that by tweaking the parameters. But you can actually see that the only thing that you see in the right one is you can see all the edges of my shelves, of my books back here, of my hand, of my headphones, of my face. Whereas on the left, you can see many more details, a much more detailed picture, also with some colors and actually with a lot of background noise. So these are the two things that we're going to end up with. I think they're quite impressive because they look kind of, interesting, and we're not going to need a lot of code to implement them. So let us get right into it. So the first thing that we need to do is we need to import two libraries, and these are OpenCV, so CV2 as CV, and NumPy as NP. As always, if you haven't installed them, you go to CMD, activate the conda environment if you're using one, then type pip install opencv-python for CV, or pip install numpy for numpy. Okay, these are the two libraries that we're going to need. And the first thing that we do is we define the camera. Now, of course, if you're not using the camera or you don't want to use the camera, you can pass a video. In my case, I'm going to say camera equals video capture. Oh, sorry, cv.video capture. And I'm passing 0, which means the first camera. If I have multiple cameras, I can also say 1, 2, or whatever. If you want to use a video, what you do is you pass a file name. So my video.mp4, for example, and it will load the video. As I said, I'm going to use a camera here. So video capture 0, and now we're going to define a while true loop and an endless loop basically. And we're getting the return value and the frame when we read the camera data with every iteration. So that's basically it. Then we can define a termination here. So if, actually without these parentheses, if cv.waitKey, we're going to wait 5 milliseconds, I think it is. If that is ort x, which basically means if we click or press the X key, what happens is we break out of the loop, and then we just say camera.release and cv.destroy all windows. And what we can do here is cv.imshow of each frame. That should be pretty simple. Run the main, and we should just see the basic. Of course, I cannot do it because I'm recording right now, but if I run this without recording, I will see my face and my camera data here on OpenCV without any filters, without any effects. So that is how you output the frames of either your image or your camera data. Now, actually, I forgot one thing. When we did the imshow, we need to also add an identifier, a name, because otherwise it doesn't work. I'm going to just pick camera here. You can pick whatever you want, but you need an identifier for every time you call imshow, because otherwise the image has no title, has no name, and that might lead to confusion. So you need to do that, and then it should work. And now we're going to define the Laplacian filter here. So we're going to say Laplacian equals cv.Laplacian, and here we're going to just pass the frame. And we now need to specify the format that we want to have, and this is cv.cv_. 64F, which stands for 64-bit and a float data type, and also for one channel, because otherwise we would have to specify a 3 or something like that. So now we're dealing with 64-bit in a data type float with black and white, basically, since we're using only one channel. And this is basically the Laplacian filter applied onto the frame. And now what we're going to do is we're going to convert this output into the data type uint8, which is basically an integer from 0 to 255. And in order to do that, we're going to say Laplacian equals np.uint8 of Laplacian. And that's basically converting it from a float from the format that we have here. We're converting it into an integer from 0 to 255, which is exactly what we need for visualizing pixels. So this is the output that we get, and then what we do is we just say cv.imshow Laplacian, and we visualize Laplacian. That's it, and I'm going to turn off my camera right now and show you the result. So now let's run the script and see what happens. We should be able to see a Laplacian filter. Yeah, okay. I was just wondering why I have two cameras here. As you can see, okay, now we also have the camera, so you don't need to live without it. You can, actually, it's on the bottom right most of the time. Can I scale this? No, okay. But here you can see the Laplacian filter, which is basically highlighting the edges, filtering out the edges, but in a very messy way, in a very noisy way. So it's a nice effect, but it's not the same as the Canny filter that we're going to implement right now. So for the Canny edge detection, I'm going to keep the camera off because we're going to run the code over and over again and experiment around a little bit with thresholds. So we don't want to always turn off and on the camera just to see the results of what we've just written. So let us start with the edge detection of Canny. It's a very simple one. We just write, for example, edges equals cv.canny, and now we pass the frame. And here we now pass two thresholds, and these thresholds are values that we have to tweak until we find the optimal result. So let us start with 100 and 100, and then just run the cv.imshow Canny and edges. So now let us see what this looks like, and it's exactly what I showed you in the beginning of the video. Just the edges basically, but we have some noise here. For example, if I hold my hand into the camera here, probably, okay, no, I thought you were going to see the individual lines on my hand here, but it's not happening. But as I go further away and more light is coming onto my hand, you can see more details of the hand here. Whereas if I come close, you can see not a lot of details, but you can see that the threshold is actually either quite high or quite low since we have a lot of noise here. So let us just tweak these values a little bit and reduce both of them to 50 and see if the noise increases or decreases. And okay, the noise increases, of course, because the threshold is lower, so more signals pass the threshold, or more pixels, more activations pass the threshold. So we get a lot more noise here, and you can see a lot more details in my hand. So if you're interested in more details, you have to lower the threshold. If you want just the rough edges, you can increase the threshold. So let's try with 150. Maybe that's way too high. Let's see. No, it actually works. So you can see the basic edges, although you can see that a lot of the essential edges are also disappearing, so it's maybe a little bit too high. Let's try with 120. Because I want to have the basic edges of my face, my body, and my shelves here. I don't want these to disappear, but I want to have other edges just disappear. So what we can take here as an example, it's a German product, so don't be confused that the text is not English. But if I hold my hand sanitizer here into the camera, you can see the text of the hand sanitizer roughly on the screen here. Or you can see that it recognizes the edges of the individual symbols, but not in such a high detail. So you cannot really see the individual letters that much or that well. So what we could do is we could say, lower the threshold to 50 and 50, and then we'll maybe be able to see more of the text. Of course, it will be pretty noisy, but we should be able to read the text. Kind of, yes, I don't know. Yeah, you could read it. At least if you know German, you should be able to read it, yes. So as you can see, it is quite interesting and quite fun to play around with these filters. They're quite impressive and they're very easy to implement with Python. Of course, if you want to understand them mathematically, it's much more effort, but this video is about a simple way to detect edges and apply some filters in Python and OpenCV.